And this is lab 4 for physics 1, 2D spring mass oscillation lab. On the right, you just see some examples of oscillations and springs. The purpose. So the purpose of this was obviously to analyze how 2D spring mass motion, works. Then once again, for most of these, comparing experimental versus model data throughout the experiment and testing energy conservation. Um, so some overview. Obviously, so there's the mass was attached to a spring and moves in the X and Y directions for on a 2D plane, and the forces used were gravity and spring force, which I see on the right, energy always works against it. Um, and so experimental data. So I used the video that was given to us, which was just I felt simpler and was just easier. Which on the right you can just see a screenshot of the video. It's pretty simple. There's the weight with the spring attached to it, and it just oscillate around. And we also use tracker to understand the movement of this and be able to record its XY positions throughout the video. And then we save this on a CSV file. Oh, yeah. So the model setup. So after we did that, we obviously record the CSV data, changed our glow script simulation, and then add in the numerical time stepping method. So here's a little picture. I can show y'all the actual coding. So here's the actual coding I put in, and then if you run it, obviously we upload the file. You see oscillates, but once again, my things were a little off. Yeah. Um, Going back to the slide, so given parameters for this were, the mass of it was 0.402 kilograms, spring constant for this was 6.89 units per meter, Rexing length was 0.123 meters, and gravity was obviously we use 9.8 for this. Versus using this where F of gravity, which is just negative mg in the y direction, zero in the others. Spring constant, negative k, L minus LO times L hat, and then the F net were just these two combined. The motion update. So for this, on the left, you just see the different, position updates throughout the, um, on the tracker, the X and Y. And then, obviously, we calculate the velocity updates using the second law and the position update each size that was shown. Obviously, and initial velocity was, excuse me, zero. Energy analysis. So it's just kind of how like the kinetic energy was used for this, using the mass and the velocity. These are all just the different um, formulas we had to use, and basically we got total energy to be a roundabout constant. Um, Position comparison, as you saw in these, it's pretty similar. There's obviously slight deviations throughout it, but for the most part, it's pretty similar with little deviations. So oscillation period was also to be pretty similar between X and Y. I mean, basically the same. Um, Obviously slightly off for different, human errors, which, comes to our conclusion. You know, the model I feel like was, semi-predicted motion. I feel like it was pretty well. Obviously the tracker has human errors and my glove script was clearly fairly inaccurate, but I think for the most part, this was a successful lab in understanding how oscillation principles worked, at least on the 2D plane, including springs. Yeah, thank you for listening.